Good afternoon. Today I'm going to speak, can y'all hear me? Do I need to move this a little bit? Yes? Okay. Okay, so today I'm going to talk about acclimatization, what happens when you're away from the heat for a while, and then re-acclimatization. After seeing the presentations this morning, I realized that acclimatization may be like part of the perfect world for agricultural workers, but nonetheless, we're going to discuss that today. Okay, so I want to thank some people. I want to thank NIOSH and the Sunshine ERC for funding the study that I'm going to talk about, the acclimatization study. I also want to thank the students, the faculty, and the staff at USF, some of who are here today. And I absolutely want to thank my research collaborators, Dr. Bernard, Dr. Corus, and Dr. Lopez. Okay, so I'm going to talk about, I'm going to talk a little bit about why acclimatization is important. I'm going to touch a little bit on some basic physiological adaptations to acclimatization. Dr. Saka did such a nice job on all of the detailed physiological adaptations that I won't cover that very much. I'm going to look at how long to acclimatize. We do have some acclimatization guidelines. And so we'll look at those, we'll look at what our research found, what happens when you're away from the heat for a while, how long does it take to re-acclimatize, and then we're going to look at the acclimatization and re-acclimatization guidelines that Dr. Lopez and I developed. Okay, so we know that exertional heat illness is a real risk for workers, especially for workers who are out in the heat. In a study looking at heat illnesses from 2011 to 2016, out of the 25 heat illnesses or cases of exertional heat illness, 14 of those were fatal. 78.6%, almost 79% of those had no acclimatization program. This is very similar to another study that looked at heat illnesses in 20 They came up with 20 heat illnesses between 2012 and 2013. 13 of those were fatal, and of those fatal heat illnesses, none of them have had acclimatization programs. So acclimatization is very important. So this is some data, and I'll explain this study in a couple of slides, but this graph is actual data, which is why it's not nice and smooth. That just shows that, oh, that's how you do that. Okay, so this is end heart rate, and this is days of acclimatization. So you can see that as acclimatization continues, end heart rate for a given workload decreases. Interestingly, at around 6 days of acclimatization, you see a plateau in heart rate, which is about when they believe the cardiovascular adaptations, when most of them occur. So that is due to the increase in plasma volume from acclimatization, which helps to increase stroke volume. Because stroke volume increases, you have a decrease in heart rate for a given workload, and that helps to increase skin blood flow that's so important in cooling. Okay, for core temperature, again, this is real data. This is not smooth data. You have a decrease in end core temperature for a given workload. Oh, wait a minute. There we go. With increased days of acclimatization. And I'll get to this on my next slide. So you also have an increase in sweat rate. Again, this is real data. This is absolutely due to some outliers, but the general trend is for an increase in sweat rate with increase in days of acclimatization. This is good, except for in order to enhance the adaptations with acclimatization, the workers or the athletes need to make sure that they get adequate hydration. Also, sweat becomes more dilute, which is what we've already learned predominantly through holding on to the sodium and the chloride, and you begin to sweat at a lower core temperature, which means that you're able to cool yourself before your body reaches a very high core temperature. Okay, you also have a decrease in perceived exertion with acclimatization, which kind of has it's kind of a double-edged sword. A person doesn't think that they're working quite as hard, but what that can do is that can cause someone to overheat before they realize it. One study found that physiological and psychological adaptations are not necessarily married. You also have a reduced oxygen demand at a given intensity, and then as Dr. Saka already mentioned, because the physiological adaptations of improving aerobic fitness are very similar to those that come about with acclimatization, someone who is more aerobically fit is actually going to acclimatize more easily. Okay, so these are the current acclimatization guidelines from some different industries. So OSHA and NIOSH both say 5 days of acclimatization to heat. OSHA says begin with 50% of the heat exposure, so 50% of the time that someone is usually going to be acclimatized or it's going to be working in the heat, whereas NIOSH says 5 days beginning with 20% and then increase 20% every day. The Mining and Safety Health Administration has a 6-day acclimatization beginning with 50% and then increasing, and then the military just says 2 weeks. So, and we undertook a study to see how long it takes someone to acclimatize, and then after they're away from the heat for a while, what happens to the adaptations that occurred, and then how long to re-acclimatize. So we started out with many more subjects than 18. We have complete data on 18 subjects. We acclimatized these people in a heat chamber at 50 degrees Celsius, 20% humidity. They walked on a treadmill at a work rate of 40% of their max VO2, and their max VO2 was an average of about 31. So these were not very fit people. They walked for 2 hours in the heat chamber. We looked at evidence of acclimatization as the plateau in core temperature over the last 30 minutes for 3 consecutive days. So they had to have a plateau for 3 days. We looked at the plateau visually, and then we also used 0.1 degrees Celsius, a difference of less than 0.1 degrees Celsius as being acclimatized. And based on our data, it took 6 days for our subjects to acclimatize, which is not that different from what OSHA, NIOSH, and MSHA recommend. Okay, in a very recent meta-analysis, they looked at first 21 studies, and then 12 of those studies met their criteria for inclusion. And they said that adaptations in heart rate and core temperature occur in about 5 days. The longer we acclimatize someone, as in more days of acclimatization, the greater the adaptations in heart rate and core temperature. If we want to improve core temperature adaptations, then we should increase the daily exposure, so from 100 minutes to 120 minutes, et cetera, and then to increase sweat rate adaptations, we want to increase the WBGT, particularly, though, make sure that the environment is a low humidity environment to enhance sweating. Okay, so this is, again, from our data. It's end heart rate in the unacclimatized state to the acclimatized state. This is the data from 2 weeks of decay of acclimatization. So this is the ending heart rate the first day back after being away for 2 weeks. and then the Re-Acclimatize data. And as you can see here, that after 2 weeks away, heart rate is pretty much almost back to where we were. Re-acclimatizing takes heart rate even a little bit lower than we were in the beginning. Pandolf came up with an equation to look at the percent decay of heart rate and of core temperature, and this represents about a 94% decay in heart rate over 2 weeks. Okay, this is the core temperature data after 2 weeks away. So we have unacclimatized, a decrease in core temperature with an acclimatized state. With the decay in acclimatization, we have an increase in core temperature. And then again, re-acclimatization brings the core temperature back even lower than it was before. And actually, this represents about an 89% decay in acclimatization. And so if we look at this graph and the last graph was 94% decay of acclimatization. This was 87% decay of acclimatization. The adaptations that occur more quickly, which are the ones in heart rate, are lost more quickly. Adaptations in core temperature take a little bit longer to accrue, and those are the ones that stick around a little bit longer. And in that meta-analysis, they found that for every decay day, there was about a 2.5% loss in core temperature and heart rate adaptations. They found that the only thing that determines decay of heart rate adaptations are how long a person is away from the heat. If we look at decay in core temperature, if we want to reduce that decay or reduce that loss of adaptation, we should increase the duration of the exposure and decrease the exposure environment. So more time, lower environmental conditions. Of course, that's easy in a laboratory setting, not so much in the real world. Okay, so after someone is away, how long do we need to re-acclimatize them? And several organizations have re-acclimatization guidelines. So OSHA says 5 days after 2 weeks away. MSHA says 4 days after 8 days away. And then NIOSH again says 4 days and start with 50% of the exposure. Our research found 4 days after 2 weeks away and about 5 days re-acclimatization after 4 weeks away. And in our research, we found that after 6 weeks away, there's pretty much a complete loss of acclimatization, and a person should start over completely. Okay, because heat stress is based on environmental conditions and metabolic rate and clothing, Dr. Lopez and I developed some acclimatization guidelines, as she showed you earlier, based on work rate and based on environmental conditions. So green signifies low heat stress conditions. The yellow signifies moderate heat stress conditions, and then the red signifies high heat stress conditions. So if a person is generally working in relatively moderate environmental conditions and they're doing light work, let's say they're standing, they're driving, then a person who is working in those conditions only takes about especially if it's a very low WBGT, it only takes them about 2 to 3 days to acclimatize. Someone who's doing moderate work, then pretty much they should acclimatize in about 3 to 5 days. And then someone who is doing very heavy work, regardless, they should probably acclimatize for 6 days. Okay, these are the recommendations for re-acclimatization. So the first column is a routine absence. So that could be that they're just on vacation or they've been assigned somewhere else. So again, green, low heat stress, yellow, moderate, red, high heat stress. As you can tell, there is a greater acclimatization with, so if someone is away from the heat for 1 to 3 days due to an illness, they should acclimatize more than someone who is just away for a routine absence. So in conclusion, like I said, I think this is probably more the perfect world than the real world in terms of agriculture. Heat acclimatization is important, and every little bit helps, I believe. It seems like, based on all the recommendations, that adaptations can generally occur in about 5 to 6 days, and that acclimatization should be based on work rate and environmental conditions. Once a person is away from the heat, obviously the adaptations of acclimatization are lost, and so a re-acclimatization schedule is needed. Thank you.
So I've got 3 questions that all go hand in hand.
Okay.
So, and just to put it in the context of the ag workers. Thanks. So first of all, speculate, with others in the room about if you were going to take the watermelon pickers, for example, and put them in your chamber, how might that sort of affect rates? That kind of work. How might that shift your estimates of acclimation? So as opposed to walking on a treadmill, something that sounds like very aerobic as opposed to this mixture of different activities. So that. Second, a lot of workers make their way, clearly not all, but they migrate from place to place. So what exactly does acclimation mean when they're going from Central Florida to North Florida to North Carolina? Are there sort of confidence bands around temperature and humidity that sort of says, okay, well now acclimation is needed as opposed to not needed? So just talk about that just a little bit. And I lost my other question, so just go with those 2.
Okay. So first of all, the watermelon pickers, that would be probably more moderate to heavy work than just walking on a treadmill because again, like I said, the work rate that we used in the lab was 40% of VO2 max. And so I don't remember what the speed was, but it was definitely less than 3 miles an hour. So it was a very, at 40% of their VO2 max, and they, like I said, they were not very fit. That's a very low level of work. So even though the activity is different, I would think that that would still be a high work rate. And so I would say 6 days. Now, and what I initially thought you meant was take those people and put them in our chamber because they're already acclimatized and they're already used to the work, then they would acclimatize very quickly, obviously.
Well, yes and no. I mean, because again, part of it is they're going from place to place to place.
Right.
So they're going to have some level of acclimate, whatever the term is.
Right.
Based on sort of one set of climate parameters. But they may have been doing a very different task when they were in Central Florida as opposed to Northern Florida, and then they'll go on and do yet a very different task then when they go up into North Carolina. So what are all sort of the attributes that come into play as far as thinking about the acclimation?
Right. So, again, I think you can kind of look at the acclimatization tables that Dr. Lopez and I developed, and it would probably be more the re-acclimatization table, depending upon how long that they were between one place and another place, and probably looking at that and the work rate that they were doing versus the work rate that they will be doing, and use that as a guide.
So Those charts where you showed lower core temperatures and heart rates after re-acclimatization,
Yes.
can you explain a little bit what accounts for that and whether you would expect that trend to continue, through more cycles like that if there were?
Sure. So, so the decay part is when the people were away from the heat. And so we just put them back through the same acclimatization protocol. And because the initial adaptations persisted, at least to some degree, then it took them less time to reacclimatize. Yes, if someone is away from the heat, sure. And again, it depends on the length, because certainly the peaks and valleys would be closer together the less time away from the heat a person is, and probably farther apart or more exaggerated the longer a person is away.
So I kind of had a related question. Those graphs imply some functional benefit of allowing somebody to get acclimated and then for it to decay and then re-acclimated, you get a lower core temperature. Is that just an artifact or an anomaly? Because I think where Joe's going is you can allow them to keep,
right.
Get them acclimated, decay, get them acclimated, decay, and at some point, they're going to be perfect no matter what. You can put them at 200-degree temperatures, and that's hyperbole.
Right. Again, I think it depends on how long. I think that might have been a bit of an exaggeration. And, the longer you decay, the less time a person has to work. And when we're talking about acclimatization, we're talking about a reduction in, the work day. So there's a loss of productivity there.
I just have one quick comment. I think it's going to be relevant to all this work. OSHA just recently changed their reporting requirements for big businesses. I don't know I have to look up the details, but now OSHA is saying that employers do not have to report incidents because they're calling it the Privacy Act, which is really, Privacy Act, which is really quite the opposite. They're saying that they're trying to protect the privacy of workers, but actually what they're doing is protecting companies from having to report these incidents. So that's going to make it really hard for everybody's research to be able to even find those incidents anymore. And I think that that's really, really telling and important to all of this research.
Yes.
It's going to make a big difference.
Absolutely.